Hello, my name is Ryan Tulloch and I am the President of ProDelta Projects. In today's webinar I'm going to talk about how we integrate remote sensing and GPS-enabled equipment into remediation and reclamation activities. With the low commodity prices and the push for environmental sustainability, ProDelta's #1 goal is to optimize our clients' budget by taking a different approach to remediation and reclamation. Our remediation reclamation activities consist of 3 different stages: aerial inspection and mapping, 3D modeling, excavation, design, and execution. I hope you enjoy our short introduction webinar. In the first part of our webinar, we're going to demonstrate how we are using manned aircraft to complete Phase 1 walkthroughs. With a large amount of remote sites, a helicopter is required for consultants anyways. However, with traditional methods of landing and walking around, this becomes extremely expensive. Using our externally mounted cameras, ProDelta completes aerial inspections quickly and easily. As all the photos are geo-referenced, it is easy for our clients to import them into a GIS system to quickly sort. Here are a few examples of how we have completed aerial inspections. So as you can see, all the photos are overlaid on the lease site. For privacy reasons, we didn't bring in the lease locations. And simply we just click on it and you can see what you need to. By zooming in, you can zoom in and get a better detail of what's going on. This is a great way to start screening sites. When we're doing this type of work, we're completing it for, depending on the quantity of sites and location, we're in the hundreds of dollars, not thousands of dollars per site. This obviously is our goal to reduce the budget of our clients at any one time. Here's a good example of a frac pond and frac site being worked out on in Northeast BC. As you can see, when you zoom in, you can get a good understanding of what's going on with the details of the pipe. For the next part of the webinar, I want to talk about how ProDelta utilizes UAVs. UAVs are a big part of our business. In regards to remediation, one of the ways we integrate the UAVs is to complete highly accurate photogrammetry surveys, and from there we get the survey data, and as well as this high-resolution orthomosaic, digital surface model, and point cloud data. I'll go into the 3D portion of the presentation a little later on and how we integrate that. First I'll go through the digital surface model and the orthomosaic. So as you can see, this is the lease site as it would show up in Google Earth or Microsoft Bing, whatever background imagery you have. It's good imagery, but you don't get a lot of detail into it. We completed the survey using the UAV, flying it at a grid pattern, with the camera pointing straight down. So as you can see, everything ties right in. And from this we can start getting a higher resolution of what's going on. You can start pulling up, there's our landing pad right there, is that little piece of carpet. You can start seeing surface features, and as well as you get a good idea of what the ground conditions are. As well as we can overlay any boreholes that have been completed, which are all these pins. For privacy reasons we didn't bring in any of the labels, which can easily be done, as well as we brought in the underground facilities. So for any future work on here, this is a great background map to be giving underground line locators and for ground disturbance as well. Additionally, we can generate a digital surface model, which is an elevation grid geotiff. So we'll go ahead and turn that on. And as you can tell, this is a fairly flat site because we don't get much of an elevation grade. However, even this approximately half a meter elevation difference can make a world of difference in the 3D model. There's some other sensors we have, including thermal sensors and multispectral. Next, before we go on to the 3D model, I'm going to go into the multispectral. So here's a lease site that was reclaimed in Northeast BC. Knowing the landowner, he let me go utilize it as a test site. It has a COR Part 2 on it and is now being used to, for agricultural purposes. So for those who are not familiar with multispectral imaging, essentially it's a way to determine plant health based on light reflectance. The human eye can only see green. However, a lot of different colors can be given off vegetation. The vegetation colors are an indication of plant health. So I'm going to go ahead and turn on the multispectral imaging. Again, this is done using a UAV on a grid pattern and processed in photogrammetry software. So here is the calculation of the Normalized Difference Vegetation Index, also known as NDVI. Red is areas of potential concern, where green is indicative of vegetation that is healthy. Because we don't have to go on the landowner's site, we can do an external survey and compare it to landowner's conditions. This can include area calculations of areas that are sparse vegetation, and additionally, there's other purposes for this. An example of another purpose where we could be utilizing multispectral imaging would be for forest fire indications, as well as for risk assessment. In risk assessment, with the argument of if vegetation is being impacted or not, if that is a concern, this could be a very good tool to show vegetation site conditions versus off-site conditions. Another use where multispectral imaging could be done is looking at doing a risk assessment. When trying to determine if vegetation impact has been done, instead of just using the human eye and looking for sparse vegetation, we can put some science behind it and fly off-site over the trees and or surrounding vegetation and compare it to on-site vegetation. With the overlays of the apex, we would be able to determine anything that was going on with it. As well, because we can put a value to the calculation, which I'll show you here right now, we can determine the areas and actually put a value and do a comparative analysis and just not doing the color. This would be a great risk assessment tool, and we are working actively with a couple clients on this. Additional sensors that we are actually currently in the final stages of development is thermal imaging. Thermal imaging can be utilized for spill purposes to determining where fluid has gone where you can no longer see it. Because of the heat differential, we are confident that we'll be able to make sure that this will help improve spill cleanups and make more effective time in the field. Check back with us later this year if you have any questions in regard to the thermal imaging. Additional data that the UAV survey can be used for is stockpile analysis and survey and quantity surveys. This is an example of a gravel pit we've completed. Additionally, we can do flyovers of potential divestitures acquisition sites to give clients a better understanding of what they could potentially be purchasing. Our next part of the webinar is we're going to show how we utilize UAV data to generate a 3D model. So part of the UAV data set that we collect is point cloud data. What that means is every pixel becomes a coordinate that could be related to a survey coordinate done with the RTK GPS system. So when we zoom in and we orbit around the site, we can start seeing 3D features. This is a fairly simple site, but you can see that there's contours. Here's the road. This black spot would be where trees were, but we took that out to help generate the surface. Surface is the lowest ground conditions. That's important for us to determine, to calculate where the boreholes that did not have elevation data to come into play. So that being said, I'm going to turn on the borehole data and I'll show you how that looks. So as you can see now, when we go underground, we can actually see the boreholes. Based on the contaminants of concern, we just color code them. Red in this indication means hydrocarbon. Yellow would indicate that there's a salt impact. Green means that analytical data was tested but no concerns. So using some different software that I won't go into details of, we can complete a 3D plume model. The plume model uses a bunch of different calculations, and then at the end of the day we bring it into our CAD software. So I'm going to show how I'm going to turn off the point cloud layer and turn on the plume layer. So as you can see, we now have the plume. Due to the nature of plumes being non-symmetrical, we actually have to generate small triangles, as you can see here. This doesn't take away from the accuracy of it, it actually puts in a bit of error into it. So as we can zoom around, we can see the interaction of the boreholes with the plume. We can do this for separate contaminants, however, we found that the easiest way is just to do it as a classification, i.e. hydrocarbons, i.e. inorganics, etc. Additionally, if we wanted to, we could bring in the stratigraphic layers. However, for today's demonstration, we'll not show that. Another alternative we could have is that we're currently working on is taking existing EM data and converting it into a 3D layer. Additionally, what you can tell is in some places we don't have proper closure. We can't say that the plume is delineated with boreholes, as you can see here on the left of the screen. This is an easy way to identify potential extra drilling and or calculate extra volume based on available data. This is a risk calculation we can do for the client and determine the risk factor of an impact to budget, i.e. is drilling worthwhile now, or is it worth the risk of doing some excavations? This also shows the benefits of how we can utilize a good detailed assessment, and where 4 or 5 boreholes won't give you a good picture, the extra money invested in an assessment can actually go a lot further. Additionally, where this actually works out really well is if we want to do a risk assessment. If we were to go and build our plume model based on risk assessed or numerical values, as we did now, we can show the difference between that and risk assessment values. We can easily show that visually and give both the regulators, who we've talked to, a good indication of how we're going to excavate it. The risk assessment excavations are going to be quite popular, however they're going to be hard to execute in the field because at the end of the day you're trying to go off values that you can't see. Completing the 3D model early on after the initial drilling is a great way to actually start looking at sites in a different way. From being able to calculate and determine borehole locations for further drillings, anticipated remediation costs, and comparative methods, etc. You can do a risk assessment versus a dig and dump versus bioremediation based on the initial model. This gives a higher level of liability associated with an individual site and determines what the next step should be. We can also show the difference in volume based on the 3D modeling quite quickly. The next step we're going to show you is how we actually do an excavation design based on this plume. Using surface calculations, we can actually calculate a top and bottom surface. This top and bottom surface will essentially sandwich this entire area. Next, I'll show you, based on if we were to dig this out, how we would show the top and bottom surfaces. So now, as you can see, these two different layers, this is what we'd call the surfaces. These surfaces are calculated, and we would take into effect slope requirements. For today's demonstration, we didn't do the full extent. However, this surface now, we can actually program this into our excavator bucket. I'll show how that's done and how the excavator would actually work in the field through a demonstration later on. The benefit of this is really when it comes to more accurate volumes than what can typically be calculated with 2D data, and additionally we can actually incorporate risk assessment values into this and then really get a good understanding of how the plume would be impacted by risk values. If you have any other questions more about this and more details, as we're only really touching the surface of our 3D modeling capabilities, please feel free to contact us at any time. Our next step was going to show how this actually is plugged into the excavator and or dozer, and we execute this in the field. If this was a reclamation site, we would just recontour based on the topographical survey collected with the UV outside of the boundaries. Following our 3D modeling and excavation design, we move into the integration into machine control. Machine control utilizes GNSS antennas and a series of sensors throughout the machine. These sensors feed back to the operator's screen and gives the operator a real-time view of where they are in comparison to the design. This allows us to complete a more efficient execution plan, as it does remove a large amount of unknown. So now that we're out in the field excavating, you can see on the screen on what the operator's view is. So taking the design that we have, we can start using the excavator, and it will tell the operator in real time if he's too high, too low, or just right. The excavator bucket is calibrated daily. As you can see here, the operator starts cutting into a slope to start sloping it properly for safety standards. This is extremely important, as this is a WCB requirement, and with the bigger excavations we do need to do side slopes based on geotechnical engineers' recommendations. Additionally, while we're digging, we can actually start generating the as-built of the excavation. As we're doing the as-built, we can actually take this back out of the excavator bucket at the end of the day and reprogram it back into our CAD model. This will be a great indication on how we would ensure that we've excavated everything out to the full extent, as a record of conditions and proof of the excavation to regulators for reporting. Because of the way we've built our model and our system, we can actually do this in near real time. We extrapolate the surface from the excavator at the end of the day and plug it into our model and see where it fits. If there's anything that has not been excavated out properly, we can redesign a small excavation based on that quickly and execute it the next day. As I hope you can tell, we have a lot of different solutions to what we're doing with the 3D modeling and executing it in the field. In addition to excavations, we can also do surface reclamation with the same principles. and as well as that looking at bigger excavations with more overburden, we could actually use a dozer to clean off the top, saving our clients time and money. The last thing we're working on, but we're still in the infancy stage of, is virtual reality. Taking this exact same model, we've actually programmed it into our VR goggles and showed huge potential to stakeholders. For being able to identify plume size and receptors, to be able to eventually be able to virtually dig the excavation out before heading to site to determine any limitations with it. The world of virtual reality is going to be a game changer. We're looking very forward to continue working with it. Well, I hope you enjoyed today's webinar and see the potential of integrating remote sensing, 3D modeling, and GPS-enabled equipment to save into remediation and reclamation. Thank you for your time, and if you have any questions, please feel free to contact me at any time. Have yourself a great day.